ดร.อดิศรยังไม่เข้ามานะครับกำลังติดต่อที่เลขาท่านอยู่ครับ
เข้ามาแล้วครับ
เข้ามาแล้วนะครับขอบคุณมากครับอาจารย์
ครับ
อาจารย์อดิศรเข้ามาแล้วครับ
Good morning. Hello from
Morning.
to all you in Thailand and wherever you are. Excellency, honored guests, participants, ladies and gentlemen, welcome to the opening ceremony of the 2021, the International Conference on Power, Energy and Innovations, ICPEI 2021. My name is Assistant Professor Dr. Attapon Manidang. I'm currently a faculty member at the School of Chemical Engineering, Suranaree University of Technology or SUT.
And my name is Assistant Professor Dr. Veena Phanpeng. I'm from School of Mechanical Engineering, and we both will be the moderator for the opening session for you today. It is my pleasure today to welcome you all to the International Conference on Power, Energy and Innovations, or in short, ICPEI 2021, held in Nakhon, Ratchasima, Thailand. And in this year, with the COVID-19 pandemic continuing to have a huge impact on the face-to-face scientific meeting and throughout the world, we shift the traditional conference to the virtual platform like we have today. And we are honored that we have you all come and join us this conference today.
Yes, and the main theme for this conference is the power, energy, and innovations. And we provide you a forum involved with electric power and energy engineering to share ideas and results. And each manuscript will be reviewed, and the full manuscript will be submitted for the inclusion into the IEEE Explore database.
Yeah, as you are no doubt aware, this conference is under the sponsorship of IEEE Thailand sections and IEEE PES Thailand chapter. This conference also organized by Electrical Engineering Academic Association Thailand, WEAT, and School of Electrical Engineering, Institute of Engineering, Suranaree University of Technology, Nakhon, Ratchasima. And yesterday, we just hosted a special lecture in the title of Optimizations in Energy Management Systems with the MATLAB workshops, which is an interesting one and especially useful topic. Ladies and gentlemen, today in the opening ceremony will consist of the report from Dean of SUT, Institute of Engineering, and also the opening remarks from the Vice Rector of SUT. And then we will do the countdown for the official opening ceremony together. Before the opening address, we first up in the program today is the multimedia presentations of our university to show you what we made in the past year and to introduce you all to know more about Suranaree University of Technology. Let's enjoy the presentation together.
With challenges emerging throughout the world, economic competition, education reform, and pedagogy have been destructively changed. Suranaree University of Technology, under the SUT Reprofile 2020 policy, has adjusted its management by envisioning the future, creating opportunities and embracing new challenges, thus enabling competitiveness and efficiently adjusting to the new normal based on the university ecosystem. Resolute to produce high-quality scientists and technologists, Suranaree University of Technology has developed modern curricula meeting the demands of the country. Encouraging lifelong learning through new generation of industrial trend curricula, upskill, reskill, and new skill courses, adjusting to on-site, online, and hybrid learning, creating lifelong learning ecosystem, as well as innovation and entrepreneurial skills for students, while simultaneously promoting professional pedagogy among faculty members to meet international standards according to the UK PSF. SUT graduates therefore embed desirable traits with knowledge and career readiness and promptness to become global citizens of the 21st century. Suranaree University of Technology's research capacity has been outstanding in terms of quantity and quality, with high recognition both nationally and internationally. Clear research directions has enabled the university to continually support research and development of innovations among full-time and young researchers. To promote specialized research which responds to the regional and national strategic development, 10 centers of excellence have been established, focusing on goal-directed research, producing high-impact and commercially viable research outcomes. The establishment of the Northeastern Regional Science Park, Nakhon, Ratchasima Province, in Suranaree University of Technology reflects strong collaboration between the state, commercial, and local education sectors to cater investments in research and development, therefore strengthening the knowledge-based economy by improving sustainability in science and technology. Suranaree University of Technology Hospital has been supporting the production of graduates and medical personnel at all levels. It includes providing medical and public health services to the general public to alleviate the loads at hospitals in Nakhon, Ratchasima, treating patients in normal times and during the COVID-19 crisis. Science, technology, and innovation has also been used for local wisdom management to preserve arts and culture of the Northeastern region, with prominent outcomes for local wisdom conservation and dissemination, aligning with the university's mission. Building quality culture within the organization has driven efficient university management, with modern digital task management, balanced financial management, efficient and full utilization of resource management, thereby strengthening the organization and connecting the university community. The path leading towards development is paved with challenges. Suranaree University of Technology maintains its stance to progress forward, together sharing the vision of the future, moving towards the goal as a country's top university, as a university truly creating values for the economy and society. Suranaree University of Technology enters its fourth decade with creativity, confidence, and pride of the region, country, and world community.
All right, for the video that just ended, it makes me love SUT more each day, and hopefully we could welcome you to our university in the near future when the pandemic leaves. And next, I'm pleased to have Associate Professor Dr. Chatchai Chotithayangun, Vice Rector for Academic Affairs and Quality Assurance in the opening address. And I also would like to invite Associate Professor Dr. Phonsiri Jongkon, our Dean from Institute of Engineering, to report to the Vice Rector the background and purposes of the conference. Dr. Phonsiri.
Your Excellency, Associate Professor Dr. Atikom Raksabut, the President of Electrical Engineering Academic Association, Thailand, Associate Professor Dr. Ratchasima, the Vice Rector of Academic Affairs and Quality Assurance, Suranaree University of Technology, Associate Professor Flight Lieutenant Dr. Kunthon Chamniprasad, ICPEI 2021, General Co-Chair, Suranaree University of Technology, Dr. Kantip Namseng-Rod, Electricity Generating Authority of Thailand, Keynote Speaker, Dr. Adisorn Theuntranont, NSTDA, Keynote Speaker, distinguished guests, delegates, ladies and gentlemen, on behalf of the Institute of Engineering, Suranaree University of Technology, it is my great pleasure to warmly welcome everyone to the 2021 International Conference on Power, Energy, and Innovations, or ICPEI 2021. The ICPEI aims to provide a forum for researchers, engineers, and industry experts to share and discuss their ideas and research in power, energy, and innovations. The conference is technically sponsored by ICPEI Thailand section and ICPEI Power and Energy Society Thailand chapter. Every manuscript submitted will be peer-reviewed and revised according to the reviewer's comments. All accepted and presented papers will be published in the abstract book and will be submitted for the inclusion in the ICPEI Explore database. We are proud and honored to be part of this event, and I am confident that the ICPEI 2021 conference will facilitate and enhance the exchanging of ideas and encourage collaboration on the challenging issues that our societies are facing today. And now, may I invite Associate Professor Dr. Ratchasima, the Vice Rector of Academic Affairs and Quality Assurance, Suranaree University of Technology, to give the opening speech and warmly welcome for participants of ICPEI 2021. Thank you.
President of the Electrical Engineering Academics Association, Thailand, Dean of Institute of Engineering, Suranaree University, ICPEI 2021 General Co-Chair, Suranaree University of Technology, Dr. Kantip Namseng-Rod, Keynote Speaker, Dr. Adisorn Theuntranont, NASDA, Keynote Speaker, distinguished guests, delegates, ladies and gentlemen. On behalf of the conference organizers, it is my great pleasure to welcome you all to the 2021 International Conference on Power, Energy, and Innovation from Suranaree University of Technology. Even though most of the participants are need to join the conference online due to the COVID-19 pandemics, as the multidisciplinary fields of power, energy, and innovation plays the most important role in the development of economic growth, including technological and environmental dimensions. Various research and development have been invented and proposed. Therefore, ICPEI 2021 is the greatest importance of the exchanging ideas, results, and challenges among researchers and engineers involved in this research area to strengthen their work and networks. The side conference will encourage collaboration in developing excellent future collaboration that may change the world. It's my honor to host you in Nakhon during the ICPEI 2021. I wish you all a successful event and gathering research networks for the future, and I hope you will have the best memorable with our organization. Thank you.
All right, thank you, the Director of SUT, for your opening remark and inspiring thoughts to start our conference. And now it's time to get excited together because we are going to start the countdown for the official opening ceremony of the conference. So shall we do that, Ajahn Chen?
Yes, of course.
Okay, if you're ready, let's count it down together.
Let's go. Wow, that marks the official opening ceremony of
That's
the
right.
2021 International Conference on Power, Energy, and Innovation. I just feel I have some power, a little bit more. Okay, and next will be the group photo session. So for the first group photo, may I invite Associate Professor Dr. Ratchasima Chotitthayangun, the Vice Rector for Academic Affairs and Quality Assurance of SUT, and also Associate Professor Dr. Atikom Gritsabut, the President of ICPEI2021, and Associate Professor Dr. Ponsari Jongkon, Dean of SUT Institute of Engineering, and Associate Professor Dr. Konthon Chamni Prasad, the General Co-Chair of the SUT. So please give us a smile so we will take the photo. Let's have a screenshot for a moment, please. Yes, that's all right. Thank you so much.
Thank you very much. And we still have them for the second group photo. I'm also pleased to have Dr. Kanchit Ngam-Sanron and Dr. Adison Turntanon, the keynote today, and Associate Professor Dr. Thanapong Suranaree, the Technical Program Chair from Thai German Graduate School, and Associate Professor Dr. Kirati Chayakunkiri, the Technical Program Chair from SUT. And please allow us to take a screenshot for a moment. Okay, all right, thank you.
That's a lovely picture. And so for all the distinguished guests, all the participants, ladies and gentlemen, please turn on your camera and that we can take a remarkable photo together. Please turn on your camera. That we will have an outstanding and a good screenshot today for this opening ceremony together. And also in the parallel Zoom meeting as well, we also keep a screenshot of all of you of the participating in this conference. Yeah, that's lovely moments. Just a moment, please hold it on. So we have a lot of participants today that we have to keep taking screenshot at the moment. Keep your smile, keep your camera. Yeah, that's lovely. Thank you so much. And next, so may I introduce our committee. So behind the organizations of this conference, without them, the conference will not be accomplished. So I would like to say many thanks to the representative from the Electrical Engineering Academic Associations, Thailand, ICPEI2021. Thank you so much for your support and every organizing in this conference. And also many thanks to the local organizing committee, the faculty members from School of Electrical Engineering, Institute of Engineering, Suranaree University of Technology. So that a lot of hard work to prepare or to organize this conference. Thank you so much.
Yeah, you are right. Thank you everyone again. And next, I would like to invite Associate Professor Flight Lieutenant Dr. Konthon Chamni Prasad, the General Co-Chair of the conference, to give a welcome speech to the Committee of the Electrical Engineering Academic Association Thailand, or ICPEI2021. Dr. Konthon.
Thank you. Your Excellency, Associate Professor Dr. Atikom Gritsabut, the President of Electrical Engineering Academic Association Thailand. Associate Professor Dr. Chatchai Chotithayankul, the Vice Rector of Academic Affairs and Quality Assurance, Suranaree University of Technology. Associate Professor Dr. Ponsri Jongkon, Dean of Institute of Engineering, Suranaree University of Technology. Dr. Kanchit Ngam Sangrod, Electricity Generating Authority of Thailand, Keynote Speaker. Dr. Adison Tranon, NASDAQ Keynote Speaker. Distinguished delegates, ladies and gentlemen. On behalf of the General Co-Chair and Local Organizing Committee, I take a great pleasure in welcoming on the attendance of 2021 International Conference on Power, Energy, and Innovation, or ICPEI 2021. In this year, the conference needs to be held mainly online, with the center at Suranaree University of Technology due to COVID-19 pandemic. However, I hope that we still keep the high quality in academic and research network contribution to future mankind living. ICPEI will enhance the highly benefit work of the researcher, engineers, academia, and innovator, and also serve as a forum for faithful discussion for our future lives, especially in the field of power, energy, and innovation. My appreciation goes to the Electrical Engineering Academic Association of Thailand, the Institute of Engineering SUT, ICPEI Thailand section, and ICPEI PAS Thailand chapter. In addition, I would like to record my thankfulness to the local organizing team, School of Electrical Engineering at SUT, of taking care of the conference arrangement. Last but not least, my warm welcome and thankful to all participants that make this conference successful. I hope you had a good time participating ICPEI 2021 and looking forward to see you in the next event. Thank you and welcome to ICPEI 2021.
All right, thank you very much. And next, I'm pleased to have Associate Professor Dr. Atikom Lerksabut, the President of ICPEI2021, to give a welcome speech to all participants. Dr. Atikom, please.
Morning, Associate Professor Dr. Chatchai Chotithayankul, the Vice Rector of Academic Affairs and Quality Assurance, Suranaree University of Technology. Associate Professor Dr. Ponsri Jongkon, Dean of the Institute of Engineering at Suranaree University of Technology. Associate Professor Flight Lieutenant Dr. Konthon Chamniprasad, ICPEI 2021 General Chair from Suranaree University of Technology. Dr. Kanchit Ngam Sanrod, the first keynote speaker from Electricity Generating Authority of Thailand, or EGAT. Dr. Adison Tranon, the second keynote speaker from NASDAQ. Distinguished guests, delegates, ladies and gentlemen. Welcome all participants to ICPEI 2021. In fact, I would like to say ICPEI 2021 is quite easy to remember. On behalf of the Electrical Engineering Academic Association Thailand, or ICPEI2021, we would like to sincerely express an honor to Suranaree University of Technology as the co-host of the 2021 International Conference on Power, Energy, and Innovations, or ICPEI 2021, and the technical sponsors as ICPEI Thailand section and ICPEI PAS Thailand chapter. Despite of the situation of COVID-19, we never stopped doing research and exchange news discoveries among the researchers and to the society. This year online conference still provides effective event for researchers, engineers, academia, and innovators to present the original work and results in the area of electrical power, any kind of energy technology, as well as the innovations and new ideas. With our researchers who have made great effort on their work, the conference should never be successful like this. Let us give great appreciation to all of them. We would also like to truly express the great appreciation to all members of the Technical Program Committee and all organizing teams for the hard work to make such an impressive conference. Finally, we wish our ICPEI 2021 participants far valuable time and good opportunity to learn and exchange knowledge from the conference and always safe from COVID-19. Welcome everyone again to ICPEI 2021. Thank you.
Thank you so much, Associate Professor Dr. Atikom Ruksabut, the President of WEAAT, for the warm welcome speech today. So, and next, we coming through the keynote sections. And next, I am very pleased to introduce our first keynote speaker, Dr. Kanchit Sangamrod. He is the expert level 12 for the power plant for the Office of the Governor, Electricity Generating Authority of Thailand. His main research interests are in the field of operations and maintenance of hydropower plant, power system operations and planning,
global energy system transition toward 3Ds. As you already know that global energy systems are currently undergoing fundamental changes that can be described as 3Ds: decarbonization, decentralization, and digitalization. The rapid deployment of many clean energy technologies in recent years accelerate the decarbonization of global energy system over the past decade. There have been a significant rise in installed capacity and generation from renewable energy source in 2018 to a total of 118 gigawatts of renewable power that were added, and bring in the global total installed capacity in renewable power to around 2,378 gigawatts. And that accounts for 1/3 of the total installed power generation capacity. It is forecast that by 2050, renewable source will provide 2/3 of whole energy, with wind and solar power make up about 48% of total global electricity generation compared to today's 9%. With the rapid the development of solar and wind power, there have been the move towards that what we call digitalization is the first one, right? With increase of distributed power generation, where the electricity is produced at or near the point of use to meet local power demand. Also, as rooftop solar installation surged over the last decade, more consumers have become energy producer, the so-called prosumer. Digitalization, digital technologies have been applied within power industry for decades. The trend toward greater digitalization has been enabled by recent development in the range of digital technologies, such as advanced analytics, Internet of Things, artificial intelligence, AI, and machine learning, and most of all, the faster communication network. Digital transformation is occurring across the energy value chain from generation to transmission and distribution, all the way to end user in home, factories, and business. The traditional power system have been built on large centralized power generation from the beginning, and a one-directional grid that deliver electricity from power plant to end user with energy With energy transition, the grid have to host more valuable renewable power and the rising level of distributed energy source and the energy storage, triggering two-way power flow within the transmission and distribution system. This means that there is a need for efficient, flexible, and reliable grid that can cope with increasingly dynamic and complex two-way energy and information flows. The development of renewable power have forced many conventional power plants that were designed were designed for baseload generation to operate increasingly at cycling mode or partial load with rapid load changes. And today, conventional power plants face four major challenges. First, they must improve operating efficiency to meet efficiencies and the regulatory target and be competitive with renewable power. Second, they must reduce our emissions to minimize the environmental impact of conventional combustion. Third, they need to be more flexible so they can respond rapidly and cycle on and off to balance the grid while remaining profitable with limited operating time. And last, there is a need to reduce unplanned downtime and improve reliable, especially when operating in a cycle mode or at a low load, as well as to reduce operation and maintenance costs. And digitalization of power generation requires many digital technologies, including big data, analytics, and AI, digital twins, cloud, and cyber security. The big data refer to the generation, storage, processing, verification, and analysis of large, highly versatile, and fast-growing volumes of data. With the objective of creating valuable information, the data collection capabilities provided by process instrumentation embedded with electronics and sensors, coupled with improved method of networking and storage, which have enabled power company to accumulate vast amount of time series data from power plant operation, laboratories, suppliers, and other sources. Together with this data contain potential insight into the operation and maintenance of every major equipment and every important process in the power plant. The challenge for power generator is to make this data useful and generate actionable insights from it. Big data analytic tools and platforms have been developed to harness this data to help power producers make informed decisions. And many power companies have actively adopted big data analytics. I mean, from in any countries. Analytics is the part of data science that use modern technologies and tools to focus on projecting future trends, events, and behaviors. Advanced analytics comprise several subgroups of analytics, such as predictive analytics, data mining, big data analytics, and machine learning, that we work together to in their predictive capabilities. Advanced analytics employ modern technologies such as machine learning and AI, deep learning, and neural networks, and visualization. Today, AI is based on varieties of disciplines, including mathematics, statistics, cognitive science, philosophies, and linguistics. So, what about advanced analytics for power plants? Advanced analytics is at the core of the next generation. Digitally transform power generation that enable intelligent operations. Big data and advanced analytics can provide power producers with insights on the state and the performance of assets, processes, and operations within the plant and the system-wide. And this will help them to make better and faster decisions to maximize the plant operational efficiencies while responding optimally to changing conditions on the grid and in the overall power market. In recent years, there has been a significant progress in the development of industrial analytics. Today, analytic solutions for control and optimization of power plants are commercially available from a well-established power generation equipment suppliers, such as ABB, GE, or MSPS from Japan, and also Siemens, as well as many software companies like IBM. For example, that I'm going to give today is the example from GE's digital power plant solution. This is a set of analytic and control applications integrated into cloud-based digital platform of GE that they call Predict. It consists of operation optimization, asset performance management, APM, and also business optimization service. The operation optimization comprises several subsystems such as fuel supply management, and boiler optimization that provide key performance indicators focus on analytic operation and optimization. So this is the one example. Actually, not only GE. On the left-hand side is the example of the platform that developed by MSPS from Japan. So what about digital twins? Digital twin is a virtual representation of a physical asset, process, or system that can capture attributes and behaviors of that entity, suitable for communication, storage, interpretation, or processing within a certain context. It consists of a sophisticated model based on deep domain knowledge of specific industrial assets. This digital twin compares data, computational models, and service interfaces as shown in this slide. The core element of digital twin is information which is related to each life cycle phase of the underlying entity and is seamlessly made available between phases. Digital twin can serve as a foundation for advanced analytics and AI application. Another example of digital twin, also again from GE. Today, numerous digital twin for power generation process are available in the market. So that is from traditional power generation technology suppliers such as ABB and some GE and some software company that I already mentioned, as well as utility engineering company like Honeywell or Berkeley. This slide shows the example of power plant digital twin that developed by GE. It integrates a collection of high fidelity computational physics-based models and advanced analytics that focus on various areas of power generation process. And GE claimed that applying this digital twin can unlock up to 8 to 13 megawatts of capacity from improved plant efficiencies, and so reduce startup time by up to 50%, reduce unplanned outages, saving the generators up to $1 million per year, and up to 10% reduction of maintenance costs. Here is another example from another provider. But I would like to give you another view that digital twin can have a wide range of applications such as design verification, system testing, and operator training that can be connected to database and with the real-time operational data to represent accurately and the present state of asset of process and the power plant. And this will enable engineers and operators to predict the plant performance and evaluate different scenarios, understand trade-off, and enhance efficiency. The example that I'm using now is the platform that developed by Emerson of USA. This company developed a digital twin that is the exactly replica of the power plant control system and can be used as a non-production test bed to validate control logic and the security patch update. Cloud computing. The cloud computing is the delivery of on-demand computing services over the internet cloud, typically on a pay-as-you-go basis. Cloud computing offers faster innovation, flexible resources, and economy of scale, and can help users run their infrastructure more efficiently at lower operating costs. Last year, more than about 150 utility companies around the world were surveyed, and 94 of the companies will power utilities. The survey found that 71 of the utilities were already using cloud services, and the pace of adoption and the rate of application being moved to the cloud, that this had accelerated in the past 2 years. This trend was set to continue as 74 of the utilities and with view that they plan to spend more on cloud computing in the next 3 or 5 years. But one of the most important is the cybersecurity. As digitalization advances, for power plant operation become increasingly independent on ICT, which increase the risk of cyber attack. The IEC identified 5 cybersecurity approach for smart energy. Among them, security by design is the most cost-effective one for cybersecurity. Hardware and software have been developed and implemented to protect energy infrastructure. Digital solutions adapting AI and machine learning for enhanced cybersecurity are under development. The next generation cybersecurity system that have been built in the form of knowledge-based system and the machine learning technology that could find the pattern in a network packet and block them automatically if they flag as a threat. Blockchain that I will be discussed next. Blockchain is considering promising technology that could help improve cyber defense. The Army work is ongoing to develop blockchain technologies to strengthen cybersecurity and to identify the information that operators need to respond on in the kind of romantic circumstance. So other digital tools such as blockchain, robot, unmanned vehicles, and smart, like what we call smart goggle, like a head-mounted display and cameras. These are being developed or under development and can play a role in the digital transformation of power generation. Blockchain is a type of distributed ledger technology. Multi-computer systems are used, and any chain to the data require consensus from all parties contained in the blockchain. This will make it difficult to destroy or tamper with. So data written to the blockchain is very secure against the hacking. Blockchain can potentially play a key role in energy trading and cybersecurity. Robots can use to perform inspection, maintenance, and repair work at especially at dangerous or difficult to reach area or site of the power plant, such as inside boiler or inside stack or towers. The bottom left figure shows the robotic crawler used for boiler water wall cleaning inspection. Using drone and robot can limit or eliminate the need to send workers to the risky pace or to time-consuming tasks that will be improve health and safety standard and saving operation and maintenance costs. One of another interesting digital tool is 3D printing. 3D printing has already successfully produced part of commercial, for example, part of commercial nuclear or gasified power plant. At the bottom right of the slide, show the 3D print component for a prototype of a nuclear reactor developed at National Laboratory of US DOE. So at this moment, 3D printing could, in the future, enable power generators to produce some part on site when they are required. This will eliminate the need to store the spare part on site that reduce the cost. So digitalization of power plant is a wide-ranging exercise based on 5 key functions listed here, from connection, monitoring, analysis, prediction, and optimization. Today, the ever faster and the appearing of connectivity provide the foundation of digital power plant by enabling the connection of sensors, device, and assets and people, and with the useful of Internet of Things provide building box of digital power plant allowing for collection, transmission, and analysis of, and also the management of operation. This can be another way that that we are going to do for digitalization of power plant. And there are 3 focus areas for power plant digital application. The first one is operation performance management. And the second is assets performance management and field service management. These are three main focus areas that even suppliers or even utilities or even the engineering company, they are going to develop such kind of this platform. This is the kind of platform that can that use for advanced analytic and control that can detect any deviation or any or adjusting operating parameter at the real time to optimize operational and environmental performance and also minimize production costs. This can be used like on, as I already mentioned, that the main component is to monitoring, diagnosis, prediction, and also the action that we need for operation and maintenance of power plant. But most of all, digital twin are behind this such kind of this application. Digital power plant or digital twin models the state of every asset, process of every process or every system. A digital power plant in digital power plants, as well as the whole power plant and by starting providing guidance on start from design, the limitation of operation of the generating unit and also the and also during the commissioning state to state the real-time operation throughout the lifetime. So digital twins also provide tools such as training, as already mentioned from the example of immersion, design and system testing, and validation of the system as well. In addition, digital tool for intelligence forecasting, portfolio optimization, and trading can help power producers to make smart business decisions, allow power trading, fuel purchase, and portfolio management to reduce financial risk and maximize profitability, maximize the operation of the work. So this is the trend that they are going to go for digitalization from generation side. And benefit for digitalization of the power plant of this will represent a step change in improving operational, environmental, and economic performance. The study showed that digital technologies could improve efficiency of conventional power plant and also CO2 emission, saving of about 469 million tons per year, or about 4.2%. The global CO2 emission could be achieved if our existing conventional power plant around the world were digitalized. The IEC estimates that the overall savings from digitalization could be in the order of about $80 billion a year over from 2016 to 2040, about 5% of total annual power generation cost. Based on the enhanced global deployment of available digital technologies to all power plants, the network infrastructure, and the reduction in the operation and maintenance cost of power generation and electricity network that could result in total saving of about $20 billion per year to 2040. This is the study that done by IEA. But what is the barriers? The popular perception of utility as analog company make it very difficult for them to attract digital talent such as data scientists and the people with specialized IoT skills. So this, given the size and also given the size of complexity and lifetime of power generation, and how can I say, some company may find it difficult to identify where to start digitalization, or maybe unclear of their objective, their priority. And also cybersecurity is a concern of power producers, especially when considering adapting cloud computing. Furthermore, digitalization requires large capital, of course, of investment. And for existing conventional power plants that are real, or maybe they're used for some time, for more than 10 years, all those profitability is squeezed due to competition from renewable generation. The plant owner, maybe the plant owner may be reluctant to commit to large investment if there is no clear path to a return to a return on of this change. That is the barrier that we are facing on digitalization of the power plant. So, for conclusion, the connection, I would like to conclude that the connection monitoring, predictions, and optimization are the foundation of power plant digitalization. The future intelligent power generation will be a data-driven cloud-enabled enterprise. Power generation will be run on a digital twin, on a digital platform, which is connected to almost everything from across the energy value chains and beyond. Big data and AI power advanced analytic tooling to digital platform that will enable power producers to analyze, learn from, and act upon the data, and to make informed decisions in all areas of that business. The digital platform can run the complex power generation operation efficiently, leading to optimal operational and environmental performance, improve real life flexibility, reliability, security, and profitability. And digital technology can significantly improve plant efficiencies and potentially reduce CO2 emission and the cost of power generation. So, thank you for your time. I'm not sure if maybe there are some parties quite very deep in the fields of power generation side, but if you have any suggestion or anything that you want to discuss, you just send me an email.
Okay, thank you. So we have some questions in the chat box. So can I read it for you? So could you further give a viewpoint in the possible structure that Thai electricity supply industry in future, and what should be our research direction?
This is the question from the chat, right?
Yes.
Okay. Actually, this is the view that I collect study from my research. This is the view from all over the world that the trend is going to be like that. And in Thailand, for example, in ICPEI that I'm working with, we are moving to that position, but maybe the platform or the naming of the system may be different depending on specific area. But the trend is look like that digital twin or how to work from everywhere. Not only at the power plant, this is the trend that's already mentioned. The concept of digital twin is going to be the trend for power from generation side. But anyway, there are a lot of trend that still underdeveloped, or maybe there are some waiting for many cases to prove the idea, like what I already mentioned, the way that we have to use a blockchain or the way that we use the data analytics with the system is not that easy because from academic point of view, we need a lot of input from the real system. This is why many companies like GE or ABB, they are trying to develop the platform that they can simulate or they can replicate the existing system and use as digital twin. So the trend is going to be like that. And as I already mentioned, there are many utilities are going to do that to do this part, but not the whole. Start from what they can do now. I'm not sure that I answer your question, but it's quite it needs a lot of information to do that.
Okay.
Yeah. Okay. Thank you.
We still have,
quite interesting. Yeah. We also have another question.
Yeah.
Please, Dr. Attapon.
Yeah. Okay. According to your talk today, the digital transformation is coming into every business and industry, especially in the area of electrical power. How should we prepare our human resources or electrical engineers for working with the new technology in the near and for the future? What is your idea?
Yes. There are many things because as you know that from the barriers that I already mentioned that in power sector fields, we are lacking of like what we call engineers or staff that they have like a kind of formative skill. So especially for electrical engineers, I think we should start from what they are studying or what kind of skill that we need to introduce to them that is very necessary for them in the future, like kind of data analytics or how can I say data science. This is one of the things that electrical engineer need to trying to study more, or if they have it will be interesting if we can add some such kind of application with the to the senior project or even to some part of the course that use the kind of this skill. This is just one example. So as I mentioned, we need a lot of people that they have a kind of formative skill to work not only in electrical fields. I mean in any fields that that we can be part of digitalization in the near future.
Okay, thank you very much, Dr. Kanchit. So thank you for your presentation and the sharing. And the next we will have another keynote speaker today. And the next we honor to introduce you our second keynote speaker, Dr. Adisorn Teuntanon. He received his PhD in electrical engineering, photonics, and MEMS from University of Colorado at Boulder in 2001. Now he is a member of Thai Academy of Science and Technology Foundation, or TAST. Recently, he worked as an executive advisor at Thai Advanced Institute of Science and Technology, National Science, Technology, and Innovation Policy Office at the Ministry of Science and Technology of Thailand from 2016 to 2017. Without further delay, I would like to have Dr. Adisorn Teuntanon to give his talk in the topic Graphene Innovation in Energy Storage Applications. Please welcome Dr. Adisorn.
Thank you very much. Everyone hear me clearly?
Yes, it's clear.
Okay. Let me share the screen. Okay. Everyone see the screen perfect? Is it all right? Okay. Okay. Let me let's say a little bit use these opportunities to thank you the organization of ICPEI 2021 and also especially to Dr. Pirati and also Dr. Atikom to invite me to give a keynote in this presentation in this conference. And today's presentations will be on the graphene innovation in energy storage and applications. I came from National Security and Dual Use Technology Center, National Science and Technology Development Agency. And also thank you to give me a chance to update our research in graphene innovation. And if you can go to the website www.graphenethailand.com to further investigate in what we are doing in the research. Okay. First of all, let me use this slide to acknowledge the funding agency that we all got from NRCT, also the Ministry of Energy Storage Program, Thailand Research Fund, EGAT program, and also PTTEP and PMUC. And the last but not least, Natural Resource Society of Thailand, that I'm working as the General Secretary for MRF Thailand. And also acknowledge the Torre Science Award, Torre Science Foundation, and also TRF for the TRF Senior Research Scholar, and NRCT for many chance to give me opportunities to have a research work. And on the right side of the slide, I show you what we are located in Thailand Science Park in Pathum Thani. This is the building that we located in the incubator 2, and inside in our labs we have a bunch of the equipment related to battery and capacitor facilities in the building. And we are very warm welcome if anyone would like to do the research in battery and supercapacitor. We can have a collaborate later. Okay, let me start. Advanced carbon nanomaterial is one of the material that's really interesting nowadays, and is well known for the unique properties. They are come from in many form or many categories. We can classify it into 3 or 4 categories, depend on its dimension. For example, if we look at it at the dimension 0 or 0 dimension, it means that it's really, really small in X and Y and Z dimensions. In this, for example, you can see a lot of advanced carbon nanomaterial in 0 dimension, like graphene quantum dot, fluorine, and also the carbon dot. At the same time, if you looking at the 1-dimensional carbon material, you might familiar with something like single wall carbon nanotubes or multi-wall carbon nanotubes, which just look like a 1-dimensional structure. And also, recently, the human just discover 2-dimensional materials in the form of the carbon, we call the graphene, and also the 3-dimensional material of the carbon that we quite familiar with. For example, like a graphite material or even the diamond material is considered as the advanced carbon nanomaterial. And today I would like to just focus on only 2D materials. The unique property that advanced carbon nanomaterial is suitable for many applications, including the electrical conductivity is quite high, and high heat conductivity and high mechanical properties. Also has the stability in chemical reaction and also has a large surface area. And the last but not least is the environmentally friendliness. Let me introduce you the two-dimensional carbon material that we call graphene. Graphene is just recently discovered by two guys, Professor Andrei Kans and Professor Konstantin Novoselov at the University of Manchester. And graphene is the first two-dimensional material that ever known. And it consists of the layer of the carbon arranged in honeycomb lattice like this. You can peel off the graphene out of the graphite using Scotch tape method. That is the method that this guy has been awarded the Nobel Prize in physics in 2010. And you can get really unique properties of the carbon material we call graphene. One of the unique property of the graphene is there has a really high strength. The strength can be up to 200 times higher than the structural steel. You can use this as like a filler in the composite for the bulletproof vest, for example, or you can enhance the strength in the composite material for the structural material. And also, they have a large surface area. The surface area of 1 gram of the graphene can be as high as 2,630 square meters. If you cannot imagine how high it is, how large it is, it's about 4 soccer fields. It's about the area of the 4 soccer fields. That is the area for 1 gram of the graphene. And also, there has a high electrical conductivity. It can carry about 1,000 times electrical density compared to the coppers. That is the really unique property that really interesting in electrical engineering field, because you can make really high conductivity material. For example, you can use it like a electrode in the display material or display devices like this. And also, one of the property is they have a really thin. That's why it can be flexible up to 20% without damage. This means that if we use the graphene as the electrode material or transparent electrode material on the flexible display device, this can be really durable. It cannot break, and it can be flexible. At the same time, with its really thin layer, they can have a transparency up to 97.3%. and the most important thing is graphene is can be synthesis or fabricated from the graphite, which is really commercially available in really low cost. It can be low cost as the graphite can be low cost as $3 per kilogram, which is really cheap. So that's why this carbon nanomaterial is really interesting compared to the other form of the carbon nanomaterials. You can see nowadays they have many graphene in many forms available in the market, and also the market size of the graphene increasingly exponentially nowadays and in the future as well. So you can get 1 kilogram of graphene as low price as about $75 per kilogram. And also graphene has many applications. For example, with its unique properties in electrical conductivity, you can have a graphene used as the conductive ink in the many electronics devices, and also for the chemical sensor devices, you can use the property of the heat for heat conduction in the LED lighting. For example, you can have the property of the structural material in the automobile and also the airplane components. And also you can use its electrical property can be used as the heat RFID sensor and also flexible display or touch panel. But today I would like to focus on the application of the graphene in the energy sector. We call battery and supercapacitor. And this is the list of the unique property of the graphene that I just mentioned. But the most important thing is really low cost compared to the other advanced carbon nanomaterials. One of the example of the graphene in the field of energy is in the batteries. For example, you might use the graphene in nowadays, every day. For example, in Samsung phone, mobile phone, there is a graphene in the batteries. With the graphene in the battery of the Samsung in a Note 10 series and S series, you can charge 5 times faster than the normal batteries. Or you can use only 12 minutes to fully charge it. And also it can be increased the capacity of the battery up to 45%. And you can have a long life battery. Also for the battery for the EV, it's really exciting field. With the graphene, you can have a fast charging. You can charge it faster with a higher capacity, with a longer life, for example. Then let me move into how to use the graphene in energy storage sector. As you know that nowadays we use fossil fuel, but in the future we move into the green and clean economies. We move forward into the renewable energies era. You can see that we will decrease using fossil fuel, and we will increase using the renewable energies, which is including the wind, solar, and also biofuels, and also other source of the renewable energies. In the future, the opportunity in renewable energy is very exciting. You can see the number of the market size in each sector related to renewable energies is quite high. And you can see that if you see the energy use mix, nowadays we can generate the energies from many use source of energy. You can see that in the future, we will decreasingly use coal and oil, and also the gas, and also the nuclear. But we will increasingly using the renewable energies. You see the percentage of renewable energy nowadays and in the future is about 2 or 3 times higher. And definitely when we use the renewable energy, which is the transmitted source, it cannot available all the time. It means that the sun is not shine all day long and also all night, and also the wind cannot be blow constantly. Then the energy storage is really important. Energy storage that that we quite use it frequently is the batteries. The battery, if you see the battery cost in the past is quite high. For example, in 2010, the lithium ion battery cost is also it can be about $1,000 per kilowatt hour. But nowadays, with the a lot of energies and also a lot of research has been investigated in the battery field. The battery has been developed, and also the technology is well developed, and the price is going down. And you can see the price of the battery can be lower and lower. And nowadays, we can be the price can be about $200 per kilowatt hour, and also will continuing decreasingly in the future. And we can estimate that it can be as low as about $100 per kilowatt hour. And also, if you see the demand for the battery, for example, for the EV battery, it will increase exponentially in the future. You can see nowadays we have only about less than 100 gigawatt hour of the use of the battery in the EV, but in the future it can be up to 700 or 800 gigawatt hour of the uses of the EV batteries in the, for example, in the 2030. And also another field of the battery that is really important is for the energy storage system. For example, like a stationary energy storage system for backup the renewable energies. You can see the demands of the global energy storage deployment can be going high as 741 gigawatt hour in the 2030. And it's really important that battery should be the main technology for enabling the renewable energies in the future. And many kinds of the energy storage device that nowadays we use, not only the batteries, we also use the fuel cell, supercapacitor, can be used as the energy storage application as well. and in the research of the energy storage, we looking for something that is quite high energy density and also high power density. That's why if we look at the Laconi plot, which is the plot of the specific power and the specific energies, you can see nowadays with the lead acid battery, we can have about this power and these energies. But in the nickel metal hydride, we can have a higher. And also then in the supercapacitor, we have the high power but lower energy. But with the lithium ion battery technology, we can have a high specific energy and also quite medium specific power. But in the field of energy research, we're looking for something in this field, in this area, that has a high specific power and also high energy density. That's why we are looking for some technology that we can answer the problem. So that's why the advanced carbon nanomaterial is really important, because with this carbon nanomaterial, we can use it in the battery and supercapacitor in many forms. For example, you can mix it into the anode. You can use the carbon nanomaterial to restrain the dendrite, also to enabling the uniform charge, and also to increase the capacity. And also you can also use the advanced carbon nanomaterial in the cathode for strengthening the cathode structure, to improve the conductivity and also to increase the wettability, and in electrolyte and in the separator as well. So graphene is one of the main carbon nanomaterial that we interested to enhance the electrochemical energy storage, because it can be used in many kind of battery. For example, lithium air battery, lithium ion battery, lithium sulfur battery, including the sodium ion battery and supercapacitor. For example, in the field of lithium ion battery, graphene can be used as the anode material, and also can be design the new structure and increase the conductivity of the electrode, and to prevent the dendrite in the lithium ion battery as well. And also, for example, in supercapacitor, graphene is really important. It can be used in the mixed with the carbon electrode, and also can be increase the conductivity of the electron and also the capacity of the supercapacitor. Graphene can be fabricated by many methods. One of the methods that I just mentioned is the Scotch tape method, that the Nobel Prize has been discovered the graphene from the graphite. But there's a lot of technique to fabricate it or synthesis graphene, including the electronication, CVD technique, and also chemical technique, and also the electrolytic exfoliation technique. Each of one has the advantage and disadvantage. For example, if you're looking at the plot between the price and the qualities of the graphene, if you use the technique like a Scotch tape method, you can have a high quality but really high price. But if you use the technique like CVD technique to fabricate the graphene film, you can have a high quality but also the high price. That's why we're looking for something that high qualities and low price, which is about this area that graphene researchers still looking for technique that can answer these questions. And also not only to the form of the graphene can be in the three-dimensional form as well. For example, we can have a 2D structure form into the foam-like structure. We can have a graphene foam structure, which is look like this. You can have 2D material in the graphene, in the three-dimensional form. And this is really important for the energy storage, because with the 3D structure, you can increase the surface area and you can increase the capacity of the battery or supercapacitor. Because you increase the area, the amount of the iron can be stored in the electrode. And many techniques to form the 3D structure of the graphene, including the template and cell assembly technique. Okay, let me introduce you a recent research work on the graphene energy storage application that we have conducted in our laboratories. In our laboratory at NASDA, we can fabricate it 2D graphene using the main technique, two main techniques. One of it is the chemical vapor deposition technique or CVD technique. This is the machine, graphene CVD machine that we have in our lab. We can thermally CVD graphene on the copper, and we can have a really perfect graphene film. And also we still doing a lot of research on to convert the CO2 or carbon dioxide that is wasted from the many industry to be used CVD technique to convert into the graphene or carbon nanotube. That is a high value material. And also another technique of chemical root synthesis. We can synthesis graphene using chemical oxidation of the graphite, and also subsequently reduction into the reduced graphene oxide. And also another technique that really important that we have patents all around the world in the to make a graphene using electrochemical exfoliation. We can have a graphene in the form of the conductive ink. For example, the application of the graphene to the graphene can be used in battery, supercapacitor, and sensor and conductive ink, for example. And also with the technique for fabricate the 3D graphene, we can have mainly using CVD technique. For example, we can have a nickel foam as a template, and then we CVD graphene structure on the nickel foam, and then we can etch away the nickel foam and have the graphene in the three-dimensional form. For example, we can have a graphene foam look like this. If you're looking at a TM image, you can see the structure of the a few layers of the graphene in the 3D structure. And we can have many kind of template, not only nickel foam. We can also have a zinc oxide nano tetrapod as a template for fabricated 3D hollow graphene structure. We use the zinc oxide nano tetrapod as a template, and then we CVD graphene on the surface. Then we etch away the zinc oxide, and then we can get the really light 3D graphene structure. And also another technique that recently we really exciting to do the research is on the how to convert the bio waste into the nanoporous carbon, which is another form of the 3D carbon nanomaterial. For example, you can have a ground coffee that you wasted when you press the coffee out of the coffee machine. You have a ground coffee that you wasted. This can be used as the fertilizer, but also it's really low cost, low value. But we can have it to convert into the high value material. Also, including the bamboo waste and the palm kernel shell, you can convert it into the high surface area activated carbon using pyrolysis and carbonization technique. At the same time, we can activate it into the nanoporous carbon material that is very high surface area. We can have about up to 2,000 square meter per gram for the surface area, which is quite relative to the graphene. And you can use in the many applications, including the battery and supercapacitor. One of the battery that we interesting and we doing a lot of research recently is in the alternative battery. Is one of the battery that we looking for is the battery that beyond the lithium-ion battery. It means that in the battery we looking for the future that we see that the problem of the using of the lithium is the lithium is will be skyrocket high in price, and also lithium is quite scarce in the future. So we're looking for alternative material that will answer the question. It should be the abundant material such as the zinc, sodium, and also potassium or aluminum. But and also looking for the material that is the non-toxic material. That's why zinc is one of the alternative material that we looking for. That's why we focus mainly on the zinc ion battery. So we use the zinc ion instead of the lithium ion. With the benefit of using zinc ion battery, we can have a structure like, for example, we use a zinc as an anode, and then we use the manganese dioxide as the cathode material. Then the battery that we working is will safe compared to the lithium-ion battery. Is a non-explosive battery, and also it can be recycled up to 90%, and with a competitive capacity with the lithium-ion battery, and even the lower cost than the lithium-ion batteries. So we use the graphene to enhance the performance of the zinc-ion battery. For example, we can have a graphene coated on the zinc foil. We can also have a graphene mixed into the manganese dioxide cathode, and also you can use the graphene as a separator as well. This is an example of the project that we collaborate with Chulalongkorn University to have a power cell zinc-ion battery using graphene as an enhanced material. We can reach the capacity up to 180 to 200 milliamp hour per gram, and energy density up to 180 to 250 watt hour per kilogram, and also with the voltage about 1.4 to 1.8 volt. So you compare to other technology in the battery. Now we about in this area. Like I just explained, that we're looking for something into this area that is a high power density and also high energy density. So nowadays we are in here. So we're looking for something that moving into this area in the future. And zinc-ion battery can be, since it's not explosive, it can be used in many applications, including the safety application, like in military application and also in the energy storage application. And also another type of the alternative battery that is really exciting to present you is the sodium-ion battery. Sodium-ion battery also has a similar structure as a lithium-ion battery, but we use sodium instead of the lithium ion. We can have a carbon like a graphite and also the hard carbon as the cathode, and also we can have as an anode, and also we can have many kind of the structural material as the cathode. For example, if you compare lithium-ion battery to the sodium-ion battery, we can have a lower cost of the energy density compare. For example, if you use the sodium-ion battery, we can have about 130 US dollar per kilowatt hour, compared to nowadays the technology of lithium-ion battery is about 160 to about 160 US dollar per kilowatt hour. And also sodium is one of the most abundant substance on the earth crust. You can see that sodium is number 5 in the earth crust that is available abundantly compared to lithium. And also lately we are very exciting because many applications of sodium-ion battery not only used in the large scale stationary energy storage or smart grid, but also it can be used as a fast charging battery in the EV system as well. That's why CATL, which is one of the biggest producer of the lithium-ion battery, turn into sodium-ion battery in the future. That's really exciting for the sodium-ion battery researcher. And in our laboratory, we also using graphene and hard carbon to enhance the property performance of the sodium-ion battery as well. Using ground coffee, wasted ground coffee, we can carbonization and oxidation into the hard carbon, and we can use it into the sodium-ion battery system. For example, we can increase the capacity of the sodium-ion battery using graphene, and also we can enhance the cyclability of the sodium-ion battery using graphene. And the last energy storage device that I would like to present is on the supercapacitor. Supercapacitor is another energy storage device that used complementary with the batteries. For example, if you see the battery has a high energy density but low power density, but supercapacitor will be lower energy density but higher power density. That it can be used complementary or hybrid system. The benefit of supercapacitor is really high power and long life cycle. You can see many forms of the supercapacitor in the form of the cylindrical form like this. And inside the supercapacitor is just the carbon electrode and electrolyte. And when you charge and discharge, it will be physically absorb the ion on the surface of the carbon. So we do a lot of research recently on using the graphene to enhance the performance of the supercapacitor by using its graphene properties on the large surface area and high conductivity. We can mix the graphene into the electrode of the supercapacitor to increase the capacity. We can have up to about 500 farad per gram. And also, if you compare to the available commercial supercapacitor on the market, we can have about this high. We can have a higher power density and power energy, have a higher energy density compared to a bunch of the companies that have available supercapacitor in the market. It just highlights some of the research on how to use the graphene in supercapacitor. For example, we can have a graphene composite with the conductive polymer like polyaniline and make in the form of the nanofiber, and we can enhance it into the property of the supercapacitor. We can have up to about 690 farad per gram, which is very, very high capacity per gram. And also we can have in the form of the graphene mixed with the carbon nanotubes, and then make it into the nanofiber composite. And this can be reach about 620 farad per gram, which is also quite high. And you can see this one, we can also have a palladium as the redox material as well. And also we can use it into the coin cell and the pulse cell supercapacitor. And we can enhance the property by using organic electrolyte and using the nitrogen dope reduced graphene oxide into the electrode material. Then we can enhance the properties of the capacity up to about 530 farad per gram, which is high compared to the other research work that has been published. And also compared to the commercial lithium-ion battery and commercial supercapacitor. And also many kind of enhance the supercapacitor. We would like to enhance the voltage of the supercapacitor so we can have a high energy supercapacitor by using many techniques, including the using of the graphene and other polymers. And recently, we also investigate use coffee ground to make a nanoporous carbon and use it into the supercapacitor as well. You can see that this can be lower the cost of the supercapacitor compared to other form of the carbon that commercially used nowadays. And the performance of the coffee ground nanoporous carbon supercapacitor is quite high, or is quite high comparable to other supercapacitor available in the market. Okay, and as I said, we can reach up to 4.5 volt solid state supercapacitor using manganese dioxide and co-dose of the nitrogen and sulfur reduced graphene oxide. This is the latest just published in the journal that we can have up to 4.5 volt, which is the first time that researcher can reach that high. Okay, so I would like to conclude what I have just presented. I just would like you to aware that the energy storage is the key for the energy renewable energies in the future. And also I have been introduced you many kind of the advanced carbon nanomaterial, including 2D, 1D, 2D, and 3D structure, which is the main material that will enhance the performance of the energy storage in the future. And the graphene is the main topics that I have been talked today, including 2D graphene and 3D graphene, and also how to use the graphene in the zinc-ion battery, in the sodium-ion battery, and also in the supercapacitor. Okay, last but not least, I would like to thank you for your attention, and also would like to give these opportunities to thank you all the team members in our laboratories that contribute many research work in this presentation. And you can see more in this website. And I would like to tell you a little bit about our future project. Now we got the funding from the government to build the alternative battery pilot plant, which have a capacity about 1 megawatt hour per year at the Eastern Economic Corridor EEC in Rayong province. That this is the area that we would like to build. We will build the alternative battery pilot plant, and it will finish install all the equipment in the October next year. So in this pilot plant, we will working on the alternative battery, including the zinc-ion battery that I just tell you, and sodium-ion battery that I just mentioned to you, and also other type of the alternative battery, including the magnesium-ion battery and aluminum-ion battery. And we are very warm welcome you to visit us and also to collaborate us if you are looking to the research of energy storage in the future. Thank you very much.
Thank you very much, Dr. Adisorn Tentanon, for your interesting presentation and the sharing. I think we're running out of time, but we still have time remain for one question in the chat box, right?
So can you see the questions? So shall we read it for you? Yeah. As you mentioned, the graphene is low cost. What about the cost of the process to develop commercial products from graphenes? So in these questions, they meant the auto commercial products rather than the battery.
Okay. Let me answer in kind of the graphene is low cost. You can have the graphene in many form, like a powder or in the solution. You can use that into many applications, including not only the battery, a supercapacitor. Like I mentioned, you can also use it as a conductive polymer and conductive electrode in the many electronics devices, including the display, sensor, and so on. So the technique to use it, you can use the printing technique. You can also use the film coating technique and other technique that available in the industry now. That is not the new technique. You just use it as the ink, for example. That is really low cost and really convenient.
Okay. Thank you so much for your answer and for all of your presentation and sharing us today this quite interesting topic, and is a new technology for the battery material. Okay, thank you so much. And now we have come to almost the end of the sessions. Before ending the session this morning, I would like to invite Associate Professor Dr. Kirati Chayakunkriri the technical program chair of SUT, to summarize the International Conference on Power, Energy and Innovation this year. Please welcome Dr. Kirati.
Thank you. Okay, thank you. Good morning, ladies and gentlemen. Good morning and welcome again to ICPEI 2021, or we can call this conference in short by its nickname as ICPEI 2021. Dr. Adikom would like us to call this conference as its nickname, right? So on behalf of the technical program and local organizing committee, I would like to take this great opportunity to thank you again to ICPEI Thailand chapter, ICPEI PES Thailand, for inviting and supporting us to be a part of the High Potential Conference. Okay, now let I make a screen share for my presentation. So in this year, I am a technical program co-chair with Dr. Nathachot Rakthai Chalenchi from RMUTP. Okay. And this year, we have got a sponsor from Electricity Generating Authority of Thailand, or EGAT, Provincial Electricity Authority, or PEA, and the CHPP Company Limited, or Combined Heat and Power Production Company Limited. And the company that supports us every year is Hitachi ABB Company Limited. Okay, in this year, we start our conference by giving a special lecture on optimization in energy management system with MATLAB. Right. We have the experts from Ascendant System, or Mr. Sukhomit Sutharod, to give us a special lecture on yesterday. So for the participant who missed this special lecture, you can get into the WEWET Facebook to see it again, right? And then it is our pleasure to get a very special keynote from Electricity Authority of Thailand, our big brother, Dr. Kanchit Ngamsanrod, who is the IEEE senior member and executive summit committee of the PES IEEE Thailand chapter, to give a very good viewpoint on digitizing power and energy transformation. And then we would like to pass our thankful to Dr. Adison Trentanon for giving a very fantastic keynote on graphene innovation in energy storage application. Okay. I think there are many questions from the audience for both keynote speaking, and I think maybe you can get the answer by we can leave a message in our WEWET Facebook later. Okay. And now let me give a very brief summary of the paper that to be presented in this conference. In this year, we categorize the paper into three areas, which are power, energy, and innovation. And for power, we categorize into electric machine, motor power grid, power electronic, and railway traction system. And for the energy area, we categorize into two fields, which are energy management, renewable energy. And in this year, we have got 25 papers submitted in power area, and the accepted paper is 23. And we have 20 papers submitted in energy area, and there are 17 papers accepted. And for innovation, we have 15 papers submitted in this area, and 12 papers were accepted. So totally, we have got 60 papers submitted this year, and the paper accepted is 52. Therefore, the rejection rate is 13.33. In fact, we would not like to reject any paper, but some paper I think they cannot make it complete on time. Most of the rejected paper. And this year we have got the percent of plagiarism with the average of 13.5% by checking with Turnitin. And all paper will be submitted to the ICPEI Expo digital libraries. Okay. Comparing to the historical statistic, okay, the ICPEI conference, we made a good start on 2019 with 40 papers presented, and last year we have got 73 papers submitted with 65 papers accepted. In this year, we have got a number of papers a bit lower than last year. Maybe this is due to our COVID-19 situation that we cannot make the order sure that what we can arrange the conference. Okay, this is the paper categorized by organization. We have the paper submitted from the Assumption University, Burapha University, Chulalongkorn University, Kasem Bandit University, Konkan University, King Mongkut Institute of Technology Lat Krabang, King Mongkut University of Technology Thonburi, Kasetsart University, Mahanakhon University of Technology, Naleswan University, Ratchamongkon University of Technology Isan, Ratchamongkon University of Technology Panakhon, Ratchamongkon University of Technology Thanyaburi, Rangsit University, Suan Sunanta Ratchapat University, Suranaree University of Technology, Thai Nichi Institute of Technology, Thammasat University, Ubon Ratchathani University, and the University of Limerick, Ireland. So this is obviously that we still have a strong network research. And what we found that even with the COVID-19 pandemics that forced us to arrange the conference mainly online, the paper we received still kept on the high quality in academic and research network. That contribution to our society. And now may I give some information about the Best Paper Award criteria this year. So this year, the Technical Program Committee decided to improve the presentation score to the paper award evaluation. So in this year, we select 3 high score papers in each area, and we invite 3 reviewers for each area, those who are not in the same organization with the author, to evaluate those papers. And then the presentation score from the session chair at the TPC will be included in the evaluation. The Best Paper Award, then we cannot announce at this moment, and this will be announced in the ICPEI2021 website, and the certificate will be sent to the author. So next, I would like to make a very important announcement that passed from Dr. Nakhon. So for the participant or the author, those who are not make your paper format in according to the information in the website. So please devise your camera ready manuscript. So at first, please include the copyright notice at the footnotes of page 1, okay? And then please generate your PDF file by using ICPEI PDF Express. So if you did not process your paper with the instruction, please remake the correct camera ready and send to the ICPEI2021@gmail.com as soon as possible, right? So if possible, please make it within today or tomorrow, okay? And Otherwise, we have a trouble for submitting your paper to ICPEI Explore. Okay. Okay. Finally, we have to say sorry for any inconvenience for the conference arrangement, and thank you for your participation to this conference. Finally, I hope that we will have many opportunities engaging in dialogue about power, energy, and innovation. I hope you are doing well during COVID-19 situation and have a good time participating ICPEI 2021 and looking forward to see you in the next event or ICPEI 2022. Thank you.
Thank you. Thank you, Associate Professor Dr. Kirati Chayakuntiri, for the conference summary and for the author information to give us today. Well, I like the way that you say the nickname of the conference. So ICPEI, it sounds like a happy. So we have a happy power, happy energy, and happy innovations, and also happy for the Best Paper Awards of this conference. So if you are waiting for the Best Paper Awards, it will be announced officially on the conference website. Please keep your eye on the website and waiting for the Best Paper Awards.
Okay, all right. We are coming to the important ceremony, ladies and gentlemen. I'm glad to bring you to the handover ceremony for the conference in the next years. And the 2022 International Conference on Power, Energy, and Innovation will be hosted by Thai German Graduate School, or TGGS. And we would like everyone here to witness the flag handover together. Are you ready?
Yeah.
If you're ready, yeah, let's start it together.
Wow, that's quite impressive moment.
Yes.
So we hope that to meet you all again in the next year conference. Now I can't wait. So I would like to have a representative from the Thai German Graduate School, TGGS, with me today to provide us the information and invitation to attend the ICPEI 2022 next year. Please welcome the representative.
Thank you. I hope you can hear my voice well.
Yes.
Okay, thank you very much. And my slide as well.
Yeah, I can see it.
Okay, thank you very much. So good morning, honorary guests, ladies and gentlemen. On behalf of the Sirinthorn International Thai German Graduate School of Engineering, or TGGS, we would like to give an introduction to TGGS and invite everybody to join the upcoming ICPEI 2022, which will be organized by TGGS and EEAAT. May I introduce the key organizing members from TGGS. First, Professor Dr. Ing Nisai Phương-Vero-Skun, the General Chair of the ICPEI 2022. Myself, Associate Professor Dr. Somsiri Chantraskul, ICPEI 2022 Secretariat, and Associate Professor Dr. Ing Thanapong Suranaree, Technical Program Committee of the ICPEI 2022. So coming up is the video presentation about TGGS So please sit back and enjoy watching. Does it stop?
Yeah.
TGGS has been born to be the role model of industry-oriented education in Southeast Asia. This educational concept is adopted from RWTH Aachen University in Germany.
So if you want to be a good engineer, you're not just a focus on a textbook, because the textbook it's been done for many years ago. But nowadays everything is different. What the students have to do is ability to integrate all the knowledge that they learn from the different fields of the engineers and then try to solve the problem that they're facing at the industry.
The ecosystem in our TGGS is that we work as a team, and our students will not be treated as students, but they're going to be our co-workers. So when you get the project and we do the research, we listen to them as well, because we learn new things from each other. We also get the creativity and also new things from the student.
The claim of TGGS is to offer engineering education according to the German model. And that raises the question, what is the German model? I guess it's not only the curriculum of these master programs. It's more the style. It's more the expectation of the professor towards what the students have to achieve.
Since our courses here at TGGS are European Credit Transfer System equivalent, this allowed the exchange students from France, Italy, and definitely from Germany to come here and take courses or doing the research work for their master thesis. This will give the opportunity for our students to learn from the students from different countries and share the experiences and also be a part of this global society.
So research is our main target. We need to train the young generation to be able to be a good researcher in the industry. So most of our research is industry oriented. So we get the demand from the industry, and the budget is also mostly from the industry.
Well, I can definitely encourage all students to come and study here. It's a very good decision. The package here is the best you can offer to engineers, which is not only the technical quality of the programs, but this environment, which is a truly international environment, and they're all profit, they're all benefit. So yeah, I'm happy to work here. I couldn't choose a better place.
For the students, I think any kind of exchange broadens their horizons. So that is the most important part. Once you have graduated from TGGS, There are lots of opportunities. TGGS surely has a leading role in introducing those German standards of technical higher education to Thailand.
German industries have a very good collaboration with TGS, or especially TGS, because TGS is very close to a lot of German companies and to the German Thai Chamber of Commerce. And TGS has the advantage of this kind of collaboration of their students to develop their students not only within Thailand, but also beyond the borders of Thailand, especially with Germany, and here to be mentioned RWTH Aachen, which is also one of the pillars of TGGS to make it really successful and drive it on an international level.
I would say that TGGS probably one of the earliest organization in Thailand that try to work with the international company and also international level organization.
เพราะฉะนั้นนักศึกษาที่จบที่พระจอมเกล้าพระนครเหนือเชิงปฏิบัติเนี่ยผมมั่นใจว่านักศึกษาที่นี่ทำได้ดีมากๆ
We believe that the integration of industry environment into the educational process will make our graduates ready from day one to confront the challenges and wait for them in the industry career.
TGGS has been established since 2005. It is an institute that adopts the German engineering education methodology and standards based on the RWTH Aachen University model of graduate level engineering education. So as an industrial-oriented engineering graduate school, TGGS is committed to work closely with industries and government organizations in order to develop human resources that match the demand of future industry. At TGGS, we offer 5 study programs with 8 research disciplines. The study programs include CPE, Chemical and Process Engineering Program, MAE, Mechanical and Automotive Engineering Program, MPE, Materials and Production Engineering Program, ECE, Electrical and Computer Engineering Program, and RV, our new curriculums on Railways Vehicle and Infrastructure Engineering Program. The Electrical and Computer Engineering, or ECE, offers 2 curriculums. The first one is the Master of Engineering in Electrical and Computer Engineering, which offers 3 study plans. The second curriculum offered by ECE is the Doctor of Engineering in Electrical and Computer Engineering, which recruits both master's and bachelor degree graduates. Our Master of Engineering in ECE curriculum offers also the application for the dual degree with TGGS and RWTH Aachen University, which is the one and only Southeast Asian university which has a double degree program with Faculty of Electrical Engineering and Information Technology, or FB6 of RWTH Aachen University. So next, may I pass the microphone to Associate Professor Dr. Thanaphong Suranaree for the information on the upcoming ICPEI 2022. Please, Dr. Thanaphong.
Thank you, Dr. Suranaree, for introduction. Good morning, distinguished guests and all the participants. The press for the next year conference is going to take place at the Hamari Hotel in the North Pattaya area. So the hotel is close to Terminal 21 in the North Pattaya. So just across the street, we can go to the Pattaya beach. So you can take a virtual tour from the Amari Hotel website, and picture below show the grand ballroom. And we hope that we can organize the real open ceremony and enjoy our banquet time in that room. So next, please. So the next is the room for parallel session. So we have select a nice room and a nice place, and I think the space of the room fit quite well for the number of participants, and also the place for a break and so on. So the facility of Amari Hotel, you can see from the model in the middle. So it has a swimming pool and also the water park. Then we can relax our free time in that area after a long academic discussion during the conference, and just walk through the garden across the street. Then we can go to the Pattaya beach. And so the lobby of the hotel, and the middle is the place that we're going to set up the registration desk and also the restaurant for our breakfast time. So it looks very nice at the Amari Hotel. Next, please. We also prepare for the alternative for your accommodation. So in the same area with Amari Hotel, the Amari Oso Hotel. So the price is affordable and very nice facility. So you can see the swimming pool, the restaurant for breakfast, and a very nice view from the room, and room facilities look very nice in that picture. Next, please. For sightseeing is very interesting. So a lot of tourist attraction in Pattaya, for example, like Nongnut Tropical Garden. So in that picture, so we can enjoy the beautiful garden with the nice decoration of flowers and trees, or visiting the dinosaur park that just opened a few years ago. And we can visit the Jomtien Beach in the south of Pattaya, or the person who like to visit the temple, so they can go to Wat Yan Sangwararam, or visit the big Buddha figure at Wat Phra Yai, or even to Vihan Sien to experience the Chinese culture and so on. So some more interesting place like a Sanctuary of Truth in the North Pattaya in Bang Lamung area, which is not far from our hotel, or can visit the Buddha Mountain in Khao Chi Chan. So for the participants with kids and families, they can enjoy their time at Ramayana Water Park or Mini Siams, or take a day trip to Koh Lan or Coral Island, or even chance take time to visit the frost magical eyes of Siam as shown below. So this is our call for paper for the next year conference. We hope to welcome you all at the ICPEI 2022 next year in Pattaya. Thank you very much.
Thank you.
Thank you. Oh, so interesting, and it's very good to participate to the conference next year. And thank you very much, Dr. Somsiri and Dr. Thanapong from TGGS. And for who interested in presenting your work next year, I have to say that you have to prepare your work right now, and see you next year. We are looking forward to have your registration, and we hope to see everyone face to face again next year. And before we end the session this morning, we would like to have a closing remark from the President of ICPEI2021. May I have Associate Professor Dr. Atikom Reksabut, the President of ICPEI2021, to give a closing remark, please.
Thank you, Mr. MC. I hope that all of you agree with me that the planning session this morning is quite impressive. Especially we have very solid and fruitful knowledge from our two keynote speakers. Thank Dr. Kanchit and Dr. Adison for your very interesting presentation. And again, I'd like to thank the host for making such a wonderful video clip for handing the flag of the current host to the next host, TGGS. It's very impressive. I think many participants agree with me. And remember, even though we are going to end up this panel session, we still have parallel session in the afternoon. I hope you enjoy ICPEI. I love when our lovely MC, Dr. Veena, said, ICPEI just like happy. So I hope you agree with us. I hope that you will enjoy the parallel session in the afternoon, and I hope you can find the happy hour moment leading parallel hour in the afternoon as well. Thank you very much.
Thank you very much indeed, Associate Professor Dr. Atikom Ruksabu. I do agree with you, totally all agree with you. Okay, and now it is time for all of us to get busy with the activities and presentations in the 7 parallel sessions in the afternoon at our ICPEI 2021. And for this morning ceremony, I would like to say thank you so much for everyone to join us today, to join us this conference, and will join us next year conference as well. And special thanks go to all sponsors who support our conference. This conference may not be organized smoothly without the strong supporter.
Yes, right. And on behalf of the organizing team today, I'd like to give a big thanks to our generous sponsors. The platinum sponsor is the Combined Heat and Power Producing Company Limited, or CHPP. And the gold sponsor are the Provincial Electricity Authority, or PEA, and also the Electricity Generating Authority of Thailand, or EGAT. And another one is Hitachi ABB Company Limited. And thank you everyone once again for all participants to join us and the conference and the ceremony this morning. And you may have to wait for Mr. Postman at home because we will send you the conference souvenir like a bag, the proceeding, the polo shirt, and the pens. And thank you. Don't forget that we still have 7 parallel sessions this morning, this afternoon, and which are in the separated Zoom meeting. And now it's time for us to say goodbye to everyone and see you again in the next year for the conference at Pattaya. Goodbye.
Bye-bye. See you again next year. สวัสดีค่ะ
Goodbye.
With challenges emerging throughout the world, economic competition, education reform, and pedagogy have been destructively changed. Suranaree University of Technology, under the SUT Reprofile 2020 policy, has adjusted its management by envisioning the future, creating opportunities and embracing new challenges, thus enabling competitiveness and efficiently adjusting to the new normal based on the university ecosystem. Resolute to produce high-quality scientists and technologists, Suranaree University of Technology has developed modern curricula meeting the demands of the country. Encouraging lifelong learning through new generation of industrial trend curricula, upskill, reskill, and new skill courses, adjusting to on-site, online, and hybrid learning, creating lifelong learning ecosystem, as well as innovation and entrepreneurial skills for students, while simultaneously promoting professional pedagogy among faculty members to meet international standards according to the UK PSF. SUT graduates therefore embed desirable traits with knowledge and career readiness and promptness to become global citizens of the 21st century. Suranaree University of Technology's research capacity has been outstanding in terms of quantity and quality, with high recognition both nationally and internationally. Clear research directions has enabled the university to continually support research and development of innovations among full-time and young researchers. To promote specialized research which responds to the regional and national strategic development, 10 centers of excellence have been established, focusing on goal-directed research, producing high-impact and commercially viable research outcomes. The establishment of the Northeastern Regional Science Park, Nakhon, Ratchasima Province, in Suranaree University of Technology reflects strong collaboration between the state, commercial, and local education sectors to cater investments in research and development, therefore strengthening the knowledge-based economy by improving sustainability in science and technology. Suranaree University of Technology Hospital has been supporting the production of graduates and medical personnel at all levels. It includes providing medical and public health services to the general public to alleviate the loads at hospitals in Nakhon, Ratchasima, treating patients in normal times and during the COVID-19 crisis. Science, technology, and innovation has also been used for local wisdom management to preserve arts and culture of the Northeastern region, with prominent outcomes for local wisdom conservation and dissemination, aligning with the university's mission. Building quality culture within the organization has driven efficient university management, with modern digital task management, balanced financial management, efficient and full utilization of resource management, thereby strengthening the organization and connecting the university community. The path leading towards development is paved with challenges. Suranaree University of Technology maintains its stance to progress forward, together sharing the vision of the future, moving towards the goal as the country's top university, as a university truly creating values for the economy and society. Suranaree University of Technology entered its fourth decade with creativity, confidence, and pride of the region, country, and world community.